students. Now in this video let's see interpretation of coefficient of regression. The line of regression of y on x is y minus y bar equal to byx into x minus x bar, which can be expressed as y is equal to a plus byx into x. Okay, here this a is what? Y bar minus byx into what? X bar. As x bar y bar is one of the point on it, so it satisfies this. So a can be determined using the values of x bar y bar, and byx is the coefficient of regression of y on x. Right? Now if x is equal to x plus 1, that is increase x by 1 unit. Therefore, what is y from this? Y will be a plus byx into what? X plus 1. So it will be a plus byx into x plus byx, right? And that is same as, if you look this one, this is nothing but the old value. So y old value plus byx, as such I can write. This is a new one, right? Now that is, what does it says? The value of y will change, or what? Increase by byx units. By byx units here, right? If byx is positive, the byx is positive, then the increase in value of x will be accompanied with increase in value of y, indicating that correlation between x and y will be positive. On the other hand, if byx is negative, the increase in value of x will accompanied with decrease in y, decrease in value of y implies negative correlation between x and y. Thus byx is the rate of change of value of y for a unit increment in x. Also it represent slope of line of regression. Also it represents slope of line of regression of y on x. Similarly byx is the rate of change of value of x for a unit increment in y and 1 upon byx represents slope of line of regression of x on y. Remember this is about the coefficient of regression. If byx is the rate of change of value of y for a unit increment in x, and it represents a slope of line of regression of x on y, and 1 upon byx represents slope of line of regression on x on y. Okay, remember this part. Now let's see few properties of coefficient of regression. Properties of coefficient of regression. So first one, the algebraic signs of coefficient of correlation is same as that of regression coefficients. That is, if R is positive, it says byx positive and bxy is also positive. And if R is negative, it says byx negative and bxy is also what? Negative. Okay. Second property, coefficient of correlation is the geometric mean of the coefficient of regression. That is r is equal to plus minus square root of bxy into byx. This one. Third, if one of the regression coefficients is greater than unity, then other is less than unity. Okay, what it is? Let bxy is greater than 1. Okay, as r square is less equal 1, and you know r square is what? bxy into byx. Okay, so what does this implies? This implies bxy into byx is what? Less equal 1. So if bxy greater than 1, fine, so here this other must be less than 1. So it says bxy less equal 1 upon byx and less than what? 1. It is less than 1. Note here the values of byx and bxy are said to be consistent if, first thing, both have the same algebraic sign, and other their product is less than or equal to unity, as r square is less equal what? 1. The same thing I have been mentioned here. Both must have same algebraic sign, and you know this one thing, byx is what? R sigma y by sigma x, and bxy is what? R sigma x upon sigma y. Remember these one. These are the properties of coefficient of regression. Now let's see some examples on coefficient of regression. Example: comment on the data. A very small example is this 1 mark question. R is given, that is correlation coefficient is given, and regression coefficients are given. Now R is 0.9, which is positive, right? This is what? Again positive, and this is what? Negative. So solution for this, the data is false. Why? First property we have written, if R is positive, then bxy and byx both must be what? Positive. This is the simple thing. Okay. Another example, let's take. In a regression study, the two regression lines are these. Calculate the correlation coefficient between x and y. Also determine the standard deviation of y if sigma x is 3. Solution. What we have? Regression lines are given. Plus 6 equal to 0. It can be written as 3y is equal to 2x plus 6. That is same as y is equal to 2 by 3 times x plus 2, right? This can be written as such. So this gives us this 2 by 3 is a slope of this line. So, and it is a regression line of y on x. So it from this byx is equal to what? 2 by 3. This one we are getting, right? Again, another line is given. What? 4y minus 5x minus 8 equal to 0. That can be written as 5x is equal to 4y minus 8. That is x equal to 4 by 5 y minus 8 by 5. So this says bxy is what? 4 by 5. Once we have byx and bxy, we can easily determine correlation coefficient. Okay. Therefore, r square is equal to byx into bxy. So that is 2 by 3 multiplied by what? 4 by 5. And that will be how much? 8 by 15. That is 0.533, which is less than 1. So this gives r is equal to plus minus 0.7303. But here it will be a square root, so positive as well as negative. But byx and bxy both are what? Positive. So that implies r is what? Positive. 7303. Now the question is left for standard deviation of y. Okay. So now sigma x is given to us, that is 3, and sigma y is unknown for us, right? So we have r, we have byx, bxy, so you can use any one of them. Okay, as bxy is equal to r into sigma x upon sigma y. So that gives 4 by 5. bxy is 4 by 5. That is equal to, what is r? 0.7303 into sigma x with us sigma y. So simplifying it, take this sigma y to this side, take this 4 by 5 to this side. So we get sigma y is equal to 0.7303 multiplied by 3 into 5 upon what? 4. Simplifying it, we get sigma y is equal to 2.7386 as such. This is the answer here. The means of x and y in a bivariate data are 30 and 40 respectively. The line of regression y on x is parallel to the line y is equal to x. The correlation coefficient between x and y is 0.6. Find equation of two lines of regressions. So what is given? X bar is 30, y bar is what? 40. Also r between x and y is given to us, that is 0.6. Okay. Now as line of regression, y on x is, what does that? It will be y minus y bar is equal to r into sigma y by sigma x into x minus x bar. Okay, so it is y minus 40 equal to 0.6 into sigma y by sigma x into x minus 30. Okay, call it as equation number 1. Now it is given to us, given that this line 1 is parallel to line of regression y on x is parallel to y is equal to x, parallel to line y equal to x. So if these are parallel, then their slopes must be equal. Here what is the slope? 1, and here the slope is this 0.6 into sigma y by sigma x. So this implies 0.6 into sigma y by sigma x is what? 1. That also gives sigma x by sigma y is what? 0.6. Call it as equation number 2. Now here we can put this value here in 1. So we get equation of line of regression y on x. Therefore 1 implies, 1 gives us what? Y minus 40 is equal to 1 into x minus 30, and that is same as y is equal to, this 40 will come on this side with positive sign, y is equal to what? X plus 10, right? This is one line, right? And now suppose we have to find equation of line of regression, other line, that is x on y, line of regression x on y. What it is? It is x minus x bar equal to r into sigma x by sigma y into y minus y bar, right? So this gives x minus 30 is equal to r is what? 0.6, and what is sigma x by sigma y is also 0.6 into y minus 40. This is from 2. I can see, and given things, right? So after simplifying it, we get x is equal to 0.36 times y. This product will be 0.36 multiplied by this. This 30 will come here, 0.36 into 40. That addition will be 15.6. This is regression line x on y, right? This is y on x. That is the answer of this question. Two lines of regression are x minus 4y equal to 5 and x minus 16y equal to minus 64. Find means of x and y. Now this is a very simple thing, as means, that is x bar and y bar, is a point of intersection of these two lines. Therefore if we solve them simultaneously, means what? X minus 4y is equal to 5. You call it as equation number 1. X minus 16y equal to minus 64. Call it as equation number 2. Now let's do the subtraction. So subtracting, this will get added and this is also get added, right? So here this x is get cancelled. Now simplifying these one, minus 4y plus 16y will be 12y, okay, and that is equivalent to what? 69. So this gives y is equal to 69 by 12. And that is y is equal to 5.75. Simultaneous simplification of these lines, as that x bar y bar is what? Point of intersection, and put in 1, suppose put in 1, what we get? X minus 4y is equal to 5. So that is x minus 4 times 5.75 equal to 5. So it will be what? X equal to 5 plus 23. This is 23. You can check. And that will be x is equal to how much? 28. Therefore, we get actually x bar is 28 and y bar is 5.75. This is the final answer here. A simple question, 2-mark question is this. Okay, remember it. Next example, solve the following. If byx is minus 1.8, bxy is minus 0.2 and variance of x is what? 4. Find standard deviation of y and covariance between x and y. Another part is what? The regression coefficient of y on x means byx is twice the regression coefficient of x on y, means byx is equal to 2 times bxy. If bxy is 0.6, find the value of correlation coefficient, means r we have to determine. Okay, a simple thing. So now first one, byx is what? Minus 1.8, bxy is minus 0.2. okay, what is with us? Variance of x, that is sigma x square, that is what? 4. So sigma x is what? Sigma x is 2. Okay, now we have to find what? We have to find sigma y and covariance between x and y. That thing we have to find. So as r is what? bxy r square into byx. So that gives r square is equal to minus 1.8 into minus 0.2. So that is r square is equal to 0.36. So that is, so r is equal to plus minus 0.6. But both bxy and byx are negative, so that implies r is minus 0.6. okay, now byx is what? R into sigma y by sigma x, anyone you can use. So minus 1.8 is equal to, this is minus 0.6, okay, into sigma y we have to find, sigma x with us 2. So what does this give? Sigma y is equal to 2 into minus 1.8 upon minus 0.6. So simplifying it, we get sigma y is what? 6. Okay, now also we have to find covariance between x and y there. We have, for that we can use a result of r. R is what? Covariance between x and y, as we have both sigma x, sigma y and r also. So that is covariance between x and y is equal to what? R into sigma x, sigma y. So that gives covariance between x and y is what? That is r is what? Minus 0.6. Sigma x is what? 2. And sigma y is what? 6. So this gives us covariance between x and y is this product, that will be minus 7.2. okay, this is the first part will finished. Now second part, it's a very simple thing. In second part already I taught byx is equal to 2 times bxy as such given to us, and another thing bxy is equal to 0.6 given to us. So what does this implies? This implies byx is what? 2 times 0.6, 2 times 0.6, and that is what? 1.2. So if byx bxy with us, how can we can easily find correlation coefficient. Therefore r is equal to what? Plus minus root bxy into byx, and that is plus minus root 0.6 into 1.2. So it is plus minus root 0.72, that is plus minus 0.8485. But bxy and byx both are what? Positive. So that implies r is what? 0.8485 is here. It is positive. That value we have to consider. Okay. Now next example. Next example, for 50 students of a class, the regression equation of marks in statistics, it is denoted by x, on marks in accountancy, that is y, is 3y minus 5x plus 180. Means x on y is given to us, right? Let me write that part first. 3y minus 5x is equal to plus 180 equal to 0. Here x on marks in this means x on y is given. So x 5x equal to 3y plus 180, that is x equal to 3 by 5 times y plus 180 times 180 by 5. This one we can write, right? Call it as equation number 1, and that can gives us one value bxy, that is what? 3 by 5 is the slope of this line. Call it as equation number 2. Okay. Now further, the mean marks in accountancy is 44. Okay. Y bar is given to us, that is what? 44. Accountancy is denoted by y, so y bar will be 44. And the variance of marks in statistics, that is variance of x equal to 9 by 16th of variance of marks in accountancy, means 9 by 16 times variance in y. This is given to us. Okay. Now what we have to find? To find what? X bar and correlation coefficients. Look at it. Find mean marks in statistics. Also find coefficient of correlation between marks in two subjects. Okay. So what is with us? X bar, y bar is a point of intersection. Point of intersection of lines of regression. If it is point of intersection of lines of regression, means it lies on both the lines. That implies x bar, y bar lies on line of regression. If it lies on line of regression, then it must satisfy that equation. Therefore, x bar, y bar satisfies 1. I can say 1. It is x on y. Therefore, 1 implies x is equal to 3 by 5 times what? Y bar with us, x bar, and that will be, let it be y bar plus 180 by 5. So that is x bar is equal to 3 by 5 into 44 plus 180 by 5. After simplifying it, we get x bar is equal to 62.4. You can check that. Okay. Now what is another part we have to determine? Correlation coefficient. So for that we can use result that bxy with us. So we can use bxy is equal to r into sigma x into sigma y. But for that we don't have sigma x as well as sigma y. So let's find out them first. And another thing is given. So using this we can find out that variance of x is equal to 9 by 16 times variance of y. That is same as sigma x is equal to root of 9 by 16 into sigma y, right? So this is what? 9 by 16, sorry, 9 by 16 times variance of y is this. So this is 3 by 4 times what? This is same as sigma x equal to 3 by 4 times sigma y. This is variance is in a square root and sigma y is outside the square root. So this gives us sigma x upon sigma y is how much? 3 by 4. Now what is with us? As bxy is equal to 3 by 5. So what does it is? bxy is nothing but bxy is equal to r into sigma x by sigma y. So that gives bxy is 3 by 5 equal to r into what? 3 by 4. So that gives r is what? 4 by 5, and that r is how much? 0.8. This one. This is a solution here. Now this is a completion of linear regression. Now in next video we will start non-linear regression. Thank you.